Jai Hind everyone. Today we are going to study polynomials. In course of polynomials, we are going to study polynomials of degree 1, 2 and 3, zeros of a given polynomial, relationship between zeros and coefficients of a polynomial, and finally division algorithm of a polynomial. Before we move on, let us see whether we remember certain things. A polynomial can be decided according to 4 characteristics. 1. What kind of variables are there in the polynomial? 1, 2, 3, many, anything. Degree of a polynomial, then value of a polynomial, and then zeros of a given polynomial. Let's study each of them. Degree of a polynomial. When we have degree 1, it is called linear. Degree 2 would go by the name quadratic. Degree 3 cubic. Degree 4 biquadratic or quartic. Degree 5 goes by the name quintic. Value of a polynomial. Let us say I have a polynomial px which goes by px equal to x squared plus 2. Now what is value of a polynomial? Let's read together. Value of a polynomial. If px is a polynomial in x and if k is any real number, then the value obtained by replacing x by k in px is called value of px at x equal to k. Now what does that mean? Let's see. As an example, let me take a polynomial x squared plus 2 as you can see on the board. Now what value of x should I put in? If I put x equal to minus 4, that is value of the polynomial. 0 of a polynomial. Now a real number k is said to be a 0 of the given polynomial if p of k is 0. In short, what value of x do I need to put into a given expression so that finally the answer is 0? For example, look at the example on the board. For a linear polynomial 2x plus 3, if we put 2k plus 3 equal to 0, k is minus 3 by 2. That means x equal to minus 3 by 2 would give me the entire polynomial as 0. So in general, now look at the last point. In general, if k is a 0 of px equal to ax plus b, then k is minus b by a. Now this is something that we need to remember in course of the chapter. Now what's new this time? What's new this time? There are 3 things that we're going to study, children. Geometrical meaning of zeros of a polynomial, relationship between the zeros and the coefficients, and finally division algorithm. Now this division algorithm is quite simplistic in the sense that we've done this before in the previous classes and we're going to do more of application. Let us see. Geometrical meaning of the zeros of a polynomial. Geometrical meaning here would mean involving the graph. Plot the graph of the linear polynomial 2x plus 3. Now this is a very simple procedure. As we all know, we're going to make tables of x and y and we're going to make the graph like this. Remember, because it's a linear polynomial, it's going to give us a straight line. Now can you see in course of this graph, where is this line cutting the x-axis? Or in mathematical terms, where is it intersecting the x-axis? Can you see? It is intersecting the x-axis in the negative side, which is minus 1.5 or minus 3 by 2. So the 0 of the polynomial is minus 3 by 2. It is, although this line is intersecting the y-axis also, but we are not concerned with y-axis. Similarly, if you look at a quadratic polynomial, now this is a pretty long polynomial if you see. But nevertheless, we know the procedure, we can solve it and we can make the graph. Now this kind of a U-shaped graph is a very characteristic feature of a quadratic polynomial. It is called a parabola. Look at this. Is it cutting the x-axis or intersecting the x-axis at 2 points? Yes. So the first 0 is minus 1, 0 as you can see, and the second 0 is 4, 0. That is, it is intersecting the x-axis at 2 points, minus 1 and 4. These are the zeros of the polynomial. Now, don't you think this method is quite interesting in the sense that you don't have to actually solve the equations to find the values or the zeros of the polynomial. Just make the graph and see wherever the graph is intersecting the x-axis, that's your 0. Now, special cases in quadratic polynomials. A question is, how many zeros do the following polynomials have? Now, let's see. Oh, the first one. I think 2. Yes. Why? Because the 2 points are A dash and A, and this graph is intersecting the x-axis at these 2 points. Same goes for B. Where is it intersecting? See, although it is a polynomial of degree 2, but still it is intersecting at only 1 point, so we shall assume that there is only 1, 0. Same way here, now this parabola, if you see, it is not intersecting the x-axis anywhere, right? So how many zeros? Yes, you got that right, no 0. Same way here, no 0. Now this gives me some more examples. These are 6 small graphs. If you can see, the first one intersects at 1 point, so 1, 0. The second one, 2 points, 2 zeros. The third one, how many? Tell me. Yes, 3. Fourth one, 1. See, the fourth one is a little tricky. Look at the fourth part. The fourth part, the line is intersecting the x-axis only at 1 point, and the other point is on y-axis. So please do not get confused with that. The fifth part, yes, 1 point, and the sixth part, 1, 2, 3, 4. Look at the curves like this. It is 4 points. Testing time. Solve exercise 2.1 and see if you can get the answers. Now this is exercise 2.1 of your NCERT, and let us solve that together. The first question says, graphs of y equal to px are given below for some polynomials px. Find the number of zeros of px in each case. You can take a second and see. The first point, yes, no 0. Second part, 1, 0. Third part, 1, 2, 3, 4. Can you see the graph like that? 4 points, so 4 zeros. Fourth part, 2 zeros. Fifth part, I can see it is 4 zeros. And the sixth part is quite an interesting graph, goes up and down, 1, 2, 3 zeros. Looks like 4, 5, but actually it is 3 zeros. Now what is new this time? The first point was geometrical meaning of the zeros of a polynomial. Now let us see relationship between zeros and coefficients of a polynomial. Quadratic functions. This is also known as quadratic functions, sum and product of roots. Before we move further to this topic, let us recall what is the standard form of a quadratic polynomial. Here we are going to confine ourselves to quadratic polynomials, and remember, any standard form of any polynomial goes in descending order of powers. That is, if it's a quadratic polynomial, first power 2, then power 1, and then the constant. Now the objectives here are to find sum and product of roots without knowing the actual value of x. See, in the first part of the chapter that we did not solve the polynomial. Here also we're not going to solve the polynomials, and we're going to find out the roots, their products, and try to find out the roots. Then look at this. Given alpha and beta are roots of a quadratic equation. Roots of a quadratic equation, let's emphasize a bit on this. If it is a quadratic polynomial, children, it's bound to have 2 roots or 2 zeros. They might be same, but then there will be 2 different entities altogether. Let us say they are alpha and beta. Alpha and beta, as you can see, x1 is alpha, x2 beta, right? These are Greek alphabets. For example, look at the last sentence. For example, x squared minus 5x plus 6 equal to 0. Now, if you look at this polynomial, we can very well find the zeros by splitting the middle term. If we split the middle term, that is 5x, we're going to get 2 factors, minus 2x and minus 3x. On solving, it gives us the zeros 2 and 3. However, sometimes we do not need the values of x to help us solve the problem. Knowing the relationship between the quadratic equation, which is the equation, let's go back and see the last thing, x squared minus 5x plus 6 equal to 0, and its roots helps us save a lot of time. How? Let's see that. Derivation of the formula. See, the standard form that I was mentioning, look at the first sentence. Ax squared plus bx plus c equal to 0. This is the standard form. Why? Look closely. Ax squared, first the descending order, which is 2, then power 1, bx, then the constant c. It has 2 roots, alpha and beta. This tells us we can have the quadratic polynomial as x x minus alpha, x minus beta. That is what we've been doing. Now once I expand and I expand, that is simply multiply, I get the sum of zeros as minus b by a and the product of zeros as c by a. What is b here? The coefficient of x. What is a here? Coefficient of x square. What is c? The constant term. And mind you, whenever we're going to take them, we're going to take them with their signs, whether plus, whether minus. In other words, ax square plus bx plus c equal to 0 has roots alpha and beta. We can always have x square minus alpha plus beta x plus alpha beta equal to 0. Now this gives us a very important result to remember. Whenever you've got two zeros of a given polynomial, there is no need for you to multiply like we did in the second step. You can always use this concept, x square minus sum of roots into x plus product of roots is equal to 0. Now let us try. Find a quadratic polynomial, sum and product of whose zeros are 3 and 2 respectively. Now the sum is 3, product is 2. This is a very oral question, let's do it in the mind. It's going to be x square minus sum of zeros into x plus product. Sum of zeros is 3, product is 2. This gives us x square minus 3x plus 2. Application example 1. 2x square plus 6x minus 3 equal to 0. First check. Is it in standard form? Yes. Is it simplified form? Yes. Can we cancel something? No. Then let's move forward. Has roots alpha and beta. Find the value of 1 upon alpha plus 1 upon beta. Now children, here this is a pretty simple equation or simple polynomial, so you can always factorize and find out the answers. But if you get a very difficult or a very lengthy calculation, there is no point to actually solve it. That is what we're going to do here. Without finding alpha and beta, we know the value of alpha plus beta and alpha beta, right? What is alpha plus beta? Sum of roots. What is alpha beta? Product of roots. Now compare. Sum of roots is minus b by a. What is b here? 6. What is a? 2. What is c? Minus 3. So minus b by a is going to be minus 6 by 2, which is minus 3. What is alpha beta? C by a. That is minus 3 by 2. Look at this. Alpha plus beta is minus 3. Alpha beta is minus 3 by 2. And so 1 upon alpha plus 1 upon beta, you don't have to do anything. Just take the LCM and your sum is solved. That means with practice, you can actually solve this kind of a question in less than a minute, I believe. Same way. 2x, same polynomial. 2x square plus 6x minus 3 equal to 0 has roots alpha and beta. Find the value of this. What are you going to do? Yes, you got it right. Multiply and solve. See, we already know sum of roots, product of roots, and expanding, you get the values. Now here, find the value of alpha square plus beta square for a different polynomial. Now in your minds, let's do it orally. There is nothing to write here. Let's do it orally. A is, yes, 1, B, minus 2, C, minus 4. What is going to be alpha plus beta? Quickly. No, it is not minus 2. It's going to be plus 2. Why plus 2? Because it is minus b by a. B is already negative here, so minus b by a is going to be positive. Same way, alpha beta is minus 4. Now we need to find out alpha square plus beta square. Just think about it for a second. Yes, I think you got the trick. Alpha plus beta whole square. See. To find this, we use the algebraic property. Alpha plus beta whole square is alpha square plus 2 alpha beta plus beta square. Rearranging, you get alpha square plus beta square on the left hand side, and the other things, when you put in the values, you get 12. Take a second to see this. Independent practice. 2x square plus 4x minus 1 equal to 0 has roots alpha and beta. Form the equation with roots alpha square and beta square. And remember, x square minus sum of roots into x plus product of roots is equal to 0. So you get, now you're going to find out x square minus alpha square plus beta square into x plus alpha square beta square equal to 0. So basically you need to find the value of alpha square plus beta square. And in the third part, the third term, alpha square beta square is nothing but the square of the product. So here the square of the product For that, let's find out the product first. It's, yes, minus 1 by 2 and alpha square and beta square we can very well find using this concept. Right, so in order to get the equation, find alpha square plus beta square and alpha square beta square. Let's move on to division algorithm for polynomials. Now this is a pretty interesting exercise that we're going to do. We're going to divide a big polynomial by a small polynomial. I know many of you get scared by it, but then let's try and get away with the scaring thing. Ways to divide a polynomial. The first one is the factor theorem that you must have studied in class 9. Factor theorem, what do we do in factor theorem? We get a big polynomial and we use hidden trial method to find the zero of the polynomial, right? So we get a zero of the polynomial, we form it in the form of equation, then we divide the given polynomial by that zero and factorize to get the zeros, right? Now long division is nothing but a part of the factor theorem only, wherein actual division of two polynomials takes place and we factorize the quotient to get the remaining zeros. Now let's move on to division algorithm. Division algorithm we studied in primary classes. Dividend is equal to, yes, quotient into divisor plus remainder. Example. Divide 2x square plus 3x plus 1 by x plus 2. So you've got 2x square plus 3x plus 1 divided by x plus 2. If you look at this, I'll just move around a bit and tell you. Look at that. You've got 2x square plus 3x plus 1 divided by x plus 2. Look at this. The first term of the divisor, x. What do I need to do to x so that it becomes 2x square? Yes, you got that right. I need to multiply by 2x. So I multiply the entire divisor by 2x. So x into 2x gives me 2x square and 2 into 2x gives me 4x. Then we subtract as usual and you get 3x minus 4x minus x and plus 1 gets down and we get minus x plus 1. Now what do I need to do to x to make it minus x? Yes, I need to multiply by minus 1. So you get 2x minus 1 as a quotient and when you multiply you get 3 as a remainder. Now this is something that you've already done in class 8 or class 9 also. Tell me, 3 is a remainder here. So can we say x plus 2 is a factor? No, it is not a factor. When will it become a factor? When the remainder is 0. Example 2. Divide the given polynomial and verify the division algorithm. Now take a second and look at the polynomial. 3x square minus x cube minus 3x plus 5. Can we divide it like this? You can very well divide like this. But then I always suggest, as a suggestion, always make the divisor and the dividend both. Yes, both should be in descending order. That's a very valid tip that I'm going to give you. See, you get minus x cube plus 3x square minus 3x plus 5 in the dividend. And if we put the divisor also in descending order, you get minus x square plus x minus 1. This will always ensure that errors are reduced to a bare minimum, children. On division, again, we get a remainder as 3. Now, when we have to verify the division algorithm, it takes divisor into quotient plus remainder. That is, what is the divisor? Minus x square plus x minus 1 into the quotient x minus 2. So that is one term. We'll have to multiply that first and to the answer add 3. That will give you the final answer as the dividend. Please do not get confused as x minus 2 plus 3. No. We'll have to use Bottomless rules here. Now let's come to a very popular question. Find all zeros of the given polynomial. Now this is a pretty long polynomial. What is the degree? Yes, biquadratic or quartic. 2x to the power of 4 minus 3x cube minus 3x square plus 6x minus 2. If you know that 2 of the zeros are root 2 and minus 2. Now this question calls for a bit of brainstorming. See, it says find all the zeros of the given polynomial if you know that 2 of its zeros are this. Root 2. Root 2 is a 0. That means x minus root 2 is surely going to divide my given polynomial. Same way, x minus root 2 is also going to divide my given polynomial. So what is the course of action? I first divide this entire big polynomial by x minus root 2. I get something. Then I divide it by x minus root 2. That is x plus root 2 and I get something. Right? And then I'll see what to do with the other things. Right? That's the course of that's the usual course that we follow. Or now, pay attention. Rather than dividing the polynomial twice, can I multiply the two zeros? X minus root 2, x minus root 2. And I get x square minus 2. Can you see? The divisor there, it is x square minus 2. So I'm dividing it by the product of the zeros. This is saving a lot of time, children. Now when we divide, because it is given to be a factor, the remainder is going to be 0. And what is left in the quotient? I get a quadratic polynomial which I can very well factorize and get the zeros. 2x squared minus 3x plus 1. Yes, split in the middle term. Look at this. So we get the given polynomial as x squared minus 2 into 2x squared minus 3x plus 1, and when we factorize, we get the zeros as x equal to 1 by 2 and x as 1. Therefore, the zeros of the given polynomial are. Now, this is the final step wherein you write all the zeros. Root 2 minus root 2 were already given to you. 1 by 2, that is half, and 1 are the two zeros that we found now. So, this is a pretty important step that you should write. All the zeros of the given polynomial. Now let us try this. Yes, this is interesting. Obtain all other zeros. See, here they are saying all other zeros of the polynomial. Again, it's a biquadratic if two of its zeros are root 5 by 3 and minus root 5 by 3. See, in the previous question, if we go back, it was root 2 and minus root 2. Now here you've got a fraction inside the square root. Hardly matters. We know how to solve that, right? See, solution steps. Let us first find the divisor, which is x squared minus 5 by 3. Now, how did we get x squared minus 5 by 3? Yes, x minus first 0, x minus second 0, x minus root 5 by 3, x plus root 5 by 3. Then we divide the polynomial by the above divisor to get the quotient. Note that the remainder will be 0 in this case. Why? Yes, because it's given that there are two factors and we are dividing by those two factors. Then we factorize the quotient to get the answer, which is x equal to minus 1 and minus 1. See, both the factors are the same. Now remember, when both the factors are the same, one common error that students do is, because the factors are same, so they simply write x equal to minus 1. No, you need to write all the values even though they are same. Right? Now this gives us three things that we have learnt this time. Geometrical meaning of the zeros of a polynomial, relationship between the zeros and coefficients of a polynomial. What was that? Yes, sum of zeros is minus b by a, product of zeros is c by a, and division algorithm for polynomials. Right, zeros of a polynomial, we did geometrical representation, then relationship between the zeros and the division algorithm. So children, I hope you studied this chapter and you enjoyed the video, and I would just close on this closing thought. Do not worry about your difficulties in mathematics. Mind you, it was given by Albert Einstein. Do not worry about your difficulties in mathematics. I assure you, mine are still greater. So thank you very much. See you in the next video.